Electric cars and trucks are kind of the sexy electric vehicle these days, but the real action is starting to take place in the medium duty vehicle and, kind of commercial vehicles like vans and delivery vehicles, that sort of thing. That is where there's a tremendous number, well, there's a big fleet in both the United States and Canada, and there's a lot of pressure to decarbonize and to reduce costs. And there's a company, it's based out of Vancouver, got a couple factories in the US called GreenPower Motor Company that has just introduced a very interesting little medium duty vehicle designed for landscaping, that sort of thing. So I'm going to talk to Brendan Riley, the president of GreenPower. So welcome to the interview, Brendan.
Thank you very much for having me. It's a pleasure to be here.
Now, I'm fascinated by the fact that you've kind of staked out this medium duty space. You've got a school bus that you also manufacture. Tell us why you think that there's a good business case here in the medium duty space.
This has been a pitch I've had for years, not just to the marketplace, but even internally to companies I've worked for. GreenPower was kind enough to hire me and allow me to bring the product to market. My position with GreenPower and our medium duty vehicle is that with a medium duty commercial vehicle, you have meaningful payload and you have meaningful range and you have an affordable price. And I think even more importantly, you have a battery size that's really manageable for a fleet or for a deployment. I can charge a medium duty electric vehicle in my garage. It has a little bit bigger than a car, but basically a car size battery. So it's scalable. And the most expensive component on any EV is the battery. And it makes the vehicle reasonably priced. The other thing is, as the vehicles get bigger and bigger, your battery just gets heavier and heavier to do the job. And at some point, you're either moving payload or you're moving batteries. You're not moving both. And for me, the magic formula that I'd been working on for a long time and was able to really, get a product to market here at GreenPower is the medium duty product in our EV Star family.
Now, I'm kind of interested at the market niche that you're targeting here. So landscaping, construction, agriculture, public works, that sort of thing. What's the demand like in that sector?
Well, the demand in the US is huge. In Canada, it's starting to take hold. We in the EV space, we either follow mandates or we follow money. Where it's being regulated, that's a mandate. So all the clean transportation initiatives here in the US and in Canada, there's incentives that are being offered for these things. So that's where you want to look at is either the money or the mandate. Those are both really viable options. Even though viability in just a normal, unsubsidized, unregulated requirement is already there for the medium duty space. The vehicles don't cost 3x. They don't even cost 2x of what a regular internal combustion legacy vehicle cost is. So the payback cycle is doable. The issue in the truck space is that it's such a business of nickels and dimes, and there is a cost of capital, and that's got to get worked into the money and the mandates really help us. And a lot of the utilities, a lot of the municipalities, and a lot of companies are really looking to get into this space, and our vehicle is a perfect platform for that.
What kind of, now you mentioned that the batteries are a big part of this, of the cost of this, and yours comes with an 118 kilowatt hour battery. And I think, autos, an electric vehicle would be in the 70 to 90 range on average. So you're a little bit bigger. But one of the things that I do a lot of interviews about is battery technology. And I don't think most people understand just how innovative and how fast that space is changing. So would you anticipate that let's say between now and 2030, just for sake of argument, that you're going to see your batteries that you put into these vehicles get lighter, cheaper, and have longer range? Is that an expectation?
Yes, it's not only an expectation, it's necessary for our space. We don't quite have a Moore's law. Batteries move in a very lumpy fashion. You'll get these, you don't get a steady incremental, path like we do with the semiconductors. It goes in kind of fits and spurts, a new additive, a new manufacturing technology. There are some caveats. Right now, I use iron phosphate, which I've been fortunate enough and actually even just lucky enough to be exposed to early on. And I saw the real compelling nature of it. It is the dominant chemistry right now in the lithium ion family, relatively inexpensive, very stable, long life, not as energy dense as some of the other chemistries that you might be familiar with, like NMC or LCA, but very, very long life. And now competitively energy dense. Tesla's using iron phosphate now on their new vehicles. And we thought that everybody in the industry thought they were going to stay NMC, on their futures. But to answer your question about the increase in batteries, when I first got into this space in 2011, the batteries were over $1,000 a kilowatt hour. And the gravimetric energy density was about a third to a half less than what you see today. So that's the weight that you're talking about. Currently, my existing battery pack is 118.2 kilowatt hours. The same size battery pack that I'm validating right now, same space, same weight, is 140 kilowatt hours. And that's what I'm bringing to market either in my next model year or the model year after that. But that's what we're in the process of. So yes, very important to see that. And people talk about other technologies gaining, like hydrogen fuel cell with the PEM cell technology and some of the other technologies that are coming. I'm still bullish on the battery electrics. Even hydrogen fuel cell vehicles that are successful are battery dominant. And frankly, the fact that our vehicles, the cost factor is just so much less to operate, to own, to buy. You don't have these crazy scalability formulae to make them pencil. And, we actually have electrons on the grid right now. They go right into the battery and they come out of the battery and they power the vehicle. It's not quite as tortured a business proposition.
Let's talk about some of the materials that went into making this particular, the EV Star utility. You're using aluminum, which I assume is a lightweighting strategy. How do you get this strength for a commercial vehicle using aluminum?
So aluminum's 25% lighter than steel for the same strength. So you just have to add more than you think you'd have to add. So it is bulkier. It's not as efficient a material dimensionally as steel. And we still use steel in places where we need a lot of support and some more serious structure in areas. Steel is wonderful. But aluminum is recyclable, infinitely recyclable. It's made here in North America. We have tons of it. Canada has tons of it. I mean, you think of, Alcan, you think of companies that really were the backbone of Canadian industry. The fact that we could turn bauxite into aluminum really revolutionized this material. And we not only use it in our stake bed, flatbed truck that you saw, we also use it in all of our dry freight box trucks for the wall material, for the structure. We use it in our school buses with our partner Constellium, who's one of the largest aluminum. They were part of Alu Swiss, and Alcan was part of that whole mix also. But we use their interlocking technology for the bodies of our school buses. It's a superior material. And the beauty of it is that you can actually assemble it with semi-skilled labor and make a beautiful product. So we've got facilities. We own a truck body company, and we've got facilities in various locations, soon to be Canada, we're expecting, where we can send the kits up there and have them assembled very easily using, not requiring welding, using coal technology. It just, bolts together or rivets together, and it's like an erector set for business and adults.
I saw in your press release something that attracted my attention, which is that EV technologies that maximize and lighten load without compromising the structural integrity. Is that what you're talking about?
Yes.
And how unusual is this in the automotive industry? Is this an innovation or is it an adaptation of an existing approach to things?
It's been a trend in the automotive space for a long time to go to aluminum. If you have any modern vehicles, most of the suspension components, A-arms, structures are aluminum already. You've probably seen Tesla with their very advanced casting, almost injection molding of the rear structure of the vehicle. That's all aluminum. Aluminum is really the material for EVs and even for regular automotive. It's becoming the standard.
You've got another vehicle that was built on the same chassis, the EV Star refrigerated box truck. And what caught my attention here is that I'm wondering if the fact that you have such a big battery on this truck, and sounds like it's going to get even bigger, is that it doesn't allow you to do other things like run a refrigeration unit, and does that become a competitive advantage in the marketplace?
So the bigger battery allows us to run a refrigerated unit. Our real claim to fame with our refrigerated box truck and eventually all of our refrigerated units is that they run off the high voltage battery. Currently, the technology is to run off of a low voltage battery, send a lot of current on a big cable up to a refrigeration unit where you step up the voltage again. And it's convoluted and it's expensive and it's not reliable and it's all that stuff. So our approach is high voltage DC straight from the high voltage battery right up to the unit, 20% higher efficiency, 20% lower weight, huge yields on, and cost factor is roughly 15 to 30% less, depending on what model you're comparing it to. All of this dovetails together, all of these things, and it's about efficiencies and trying to make the most compelling application of our product.
I'm reading about the electric vehicle, the cars coming out now with 400 volt architecture or even 800 volt architecture. Is that what you're referring to?
Well, I mean, those are good examples of what we do already. We currently have a 600 volt architecture on one vehicle and almost 700 on the other. And the way electricity works is that the higher the voltage, the lower the current, and they're inversely proportional. If I've got 10 volts and I'm drawing 100 amps, if I go up to 20 volts, I'm only drawing 50 amps. It's very easy math. And what that lower current means is less heat, longer lasting components, and lighter weight because I can downsize. If you've been to Europe, which I'm pretty sure you have, you notice their cables are smaller, their plugs are smaller. Everything European looks like tiny when you look at the power cables and things. It's because they run at twice the voltage we do here in this part of North America.
Great. Well, Brendan, thank you very much for this. Really appreciate it, and good luck with your new vehicle.
Thank you so much. It's really a pleasure, and really a pleasure being here today.